kick off. So hello, everyone. Welcome. Thank you for attending this webinar on Statsig's Azure AI integration. This is a pretty exciting one. We launched our Azure AI integration about 2 weeks ago, and it's been pretty awesome to see the interest and excitement from everyone building with Azure AI. If you're here, you probably read a little bit about the integration, either in our launch blog post or maybe you saw it in Microsoft Ignite in Satya Nadella's keynote. But we're really excited about the potential for people building with AI and specifically Azure AI to use this integration. A little bit of context. So Statsig is an experimentation and analytics platform. We've been used by very large companies like OpenAI, Anthropic, and then also companies building with AI models like Notion, Figma, and Atlassian. And many companies have been using Statsig as a way to optimize and configure AI applications. The Statsig Azure AI integration that we announced takes us one step further by giving anyone building with Azure AI a native way to configure Azure AI models from their single platform, implement Azure AI models in code with a pretty lightweight SDK, automatically collect a variety of metrics on model and application performance, and ultimately run very powerful tests to continuously optimize your application. So to share this and to dig into like how you can actually implement this in your product, Vijaye, our CEO, is going to join and give a walkthrough and basically show how you can use this as a developer.
Awesome. Thanks, Skye. Hey, everyone. I'm Vijaye, founder CEO of Statsig. So when we started working with the Microsoft Azure team, one of the things we noticed was there's really no good way to like gather telemetry like how long did this AI request take, how many tokens did it consume, what's the latency, and then eventually like what the cost profile is. And these are all stuff that we do pretty much day in and day out at Statsig. So what we decided to do was to build an SDK that combines the best of Azure AI's capabilities along with Statsig's stats engine, so we can bring all of these data together. And when we did that, one of the cool things that came out of it is that the ability to run experiments, because chances are if you're using Azure AI, you want to understand how one model performs against another model, one prompt performs against another prompt in so many different ways. And so we wanted to make it super easy. And we built an SDK. The SDK is now available in Node.js, Python, as well as .NET. So if you're using one of those should be like relatively straightforward. Today, I'm going to walk you through how to build AI applications using this SDK. This brings together a few different concepts. One is Azure AI, and inside Azure AI, model deployments, and then text generation using the model deployments. And alongside, I'm also going to talk to you about how Statsig could be used to provide all of this configuration in one neat package. And then subsequently, every time you call these APIs, you can also start to see events flowing through. These events will have metrics like latency, token length, cost, and so on. So let's walk through one of these. I'm going to share my screen here. And in the screen, there's a few concepts that I'll touch on, and I'm going to use Node.js today for the demo purposes, and we'll build an application using Node.js, and we'll generate text. Okay, so the first thing you want to go to is npm.js. npm.js has, if you search for Statsig Azure AI, you will find our package that is available there. So here, this is what it looks like, and it also has very simple getting started help to get you going. And then there's more documentation. So if you go to docs.statsig.com, and if you look into the SDKs, Azure AI is actually one of them. And you can walk through this SDK docs. These will give you even more in detail usage examples about like how to use the various different capabilities of Azure AI and alongside sending data to Statsig. Okay, let's jump into code. I hope you all were hoping to see code, so let's jump into one of these. I have terminal open. I'll make it a little bit bigger so you can all see clearly. I'm going to create at the directory Azure AI demo 2. And then we will go ahead and initialize an application here using npm. And we now have a directory with basically just a package file. So the one thing we want to go ahead and do is to add our SDK right away. So let's copy this and go ahead and install Statsig Azure AI. And this will go ahead and add a bunch of packages. And so now we're ready to get going with code. So let's go ahead and launch Visual Studio Code. And we will have something that looks like this. There's really no code at this point, and we will have to start writing. But first, let's go ahead and create the entry point for this. And so we're going to make this a little bit bigger as well. The entry point will be main function, async function main, and then this is where we will do most of our work. So let's call that main function to make it sure that we actually invoke it. And within this, we will now have symbols loaded. So let's first go ahead and do Azure AI. In Azure AI, it'll go ahead and add all the requires for us automatically. And then first thing you got to do is initialize. And in order to initialize, you have to pass in Statsig server key. So this is the first time we're going to jump into Statsig's console. So let's go into start Statsig's console. You can go create a new account from statsig.com, and you will get access to pretty much everything that we're going to talk about today. The first thing you'll have is on the left-hand side, you'll see a set of features that are already available for you. So all of these features are ungated. You can go ahead and play with it, but we're going to focus on a few different things today, which will be dynamic config and experiments. In order to get the code compiling and initialize, we need a server SDK key. So the server SDK key could be found inside project settings, keys and environments, and within it, you can go and find there's a different sets of keys. There's server keys, client keys. For this particular demo, we will need one of the server keys. So I'm going to go ahead and copy it and bring it back here to code, and I'm going to initialize with that server key. So once that is initialized, then obviously we have to await this, and this code will run. We can verify this runs by starting the invocation of this code. It does nothing, but it goes and initializes Azure AI. Okay, so the next set of things is we want to go ahead and let's say generate some text from AI. So in order to do that, you need a model. You need some parameters that go along with the model. You also need some prompts. So in order to create one of these models, I'm going to jump into Azure AI. So this is where you would probably have an Azure AI account. You can go into the Foundry by going into ai.azure.com. And within the Foundry, so I have a couple projects, and you can go create any of these projects. So let's go ahead and create one, jump into one of these projects, and then so you will have within your assets a set of models and endpoints. For this demo purposes, we're going to go create a new model. And this is how you would create a new model deployment. So we will choose to deploy a base model. Cool thing is that Azure AI Foundry comes with about 1,000 different models that you can pick from. So today we're going to pick from actually GPT models. So when you search for GPT, you'll find several one of these available. So let's go ahead and pick 4.0 Mini for our test demo here. And for this demo purposes, I'm going to leave everything as default and go ahead and deploy it. All right, so now once the deployment is ready, you have a couple things here. So one is you can define a set of parameters within this deployment. You can get hold of the endpoint and the key, which is kind of like what we need in order to invoke these APIs. So I'm just going to go ahead and copy the URI, and let's go ahead and add it as a constant. So I'll go ahead and then we'll remove all of these paths from the endpoint. And then let's go ahead and API key equals, and we'll have to copy this and paste it. So let's keep that around. Now, once we have the endpoint and API key, we can go ahead and start invoking the AI models. So the way we do that is very, very simple. So the API, the SDKs that we've built makes it extremely easy to go ahead and like generate text from any one of these endpoints that Azure AI provides. So let's go ahead and like see how we can create a model client. So let's see, the AI client would look like this. So since we've already initialized Azure AI, we can go ahead and go gather an AI client. So there's a method called get model client from endpoint, and we will go ahead and add that endpoint, and we can pass in the API key. And now with that one single line, we have a client which we can operate on. And this client object obviously provides several methods for working with the AI model. So let's go ahead and like pick one of them, which is say complete. So this is the chat completion API. Internally, it goes ahead and calls the endpoint with the API key in the right ways, and then it'll set up all the parameters by default. And then once the response comes back, it'll actually like package that response and give it to you in a usable fashion. So first, let's go ahead and like create one of these and see what happens. You need to pass in a set of prompts. And so in order to do that, I'm going to do type, so system prompt, quickly refer to this. So you got to pass in role and content. Let's say you are a helpful assistant that talks pirate. And then now let's go ahead and say role user, and then content. Let's go ahead and have AI write us a poem. Write a poem about the planets in the solar system. Now, obviously, this is going to go ahead and create a pretty long poem. So in order to reduce the length of the poem, we're going to go and set some options. So max tokens, let's put it to 100. Okay. So let's receive the response in a response object, and we will await that. So this response object is going to have the response that comes back from the AI client, which we will then go ahead and write to console. So response dot choices, and we can do this console dot log choice dot message dot content. And that's basically it. We now have a fully functioning AI application that you can then pass in pretty much any prompt you want. So what we've done here is like we've written a system prompt and a user prompt. The system prompt basically tells AI how it should behave. And in this case, what we're saying is like you need to talk in pirate. Obviously, you're also very helpful. And then the user prompt is basically the one that keeps changing, which usually comes from the user. In this particular case, we're asking AI to write a poem about the planets in the solar system in pirate form. So let's go ahead and run this now. Oh, before we do this, one of the things that I forgot is obviously we need to do a shutdown of the Azure AI, because otherwise you're going to keep all the batched events around which are not flushed to the server. So we need to make sure that we call it. Okay, let's go ahead now, run this program and see what it spits out. And so this is going to call into the Azure AI API, and it obviously came back with a poem, with different planets, made it all the way up to Venus, and we ran out of tokens. But this is good for like demo purposes. We can like see how this works. And under the hood, all the right things happen. Now, one of the things that I mentioned at the beginning is that every one of these API calls has telemetry, and this telemetry include things like, when was it invoked, how many times the API was invoked, and then also when the responses come back, we capture everything about like the response, how many tokens it used, what the latency was, and so on, and then we capture all of that. We send it to Statsig. So here's where the benefits of Statsig show up. So if I go into events, and if I look into like in real time the events that are streaming, so you can see December 3rd, which is right now. So we have invoked and got back some usage about the Azure AI APIs. So you can kind of like see the invocation of what we're doing. We're invoking from Azure AI SDK type Node.js. And then if you go up, you can see usage. And within the usage, you can actually see more information about that particular API, which includes how many tokens were used for completion purposes. I mean, sometimes what happens is you have a budget for tokens, and you kind of like want to make sure that you ration it. And so here you can keep track of how many tokens were used. You have a latency, which tells you like this particular API took about 2.1 seconds. And the model that we use is ChatGPT 4o mini, and so on. And so this is a very simple application that calls into the endpoint using Statsig's Azure AI API, which makes it extremely easy to invoke these functions. Now, obviously, you can go ahead and like do more invocations. For example, like you can have things like get embeddings. If you're creating a RAG, a vector database, you can use get embeddings to get back all of your embeddings and throw it into a database. You also have get stream complete, which allows you to like complete all of these long completions in stream form. And then get info, which basically gets you model information about that particular endpoint. Now, so this is a very rudimentary example. Now, if you take this one step further, what we're doing here is like we're embedding a whole bunch of like information directly into code. One thing that Statsig allows you to do is to package all of that into a dynamic config. A dynamic config is something kind of like a blob store that allows you to change things in runtime without having to go update code. So I'm going to show you how you can throw all of this information that we just pulled into a dynamic config so that as the code is running, you can go ahead and update things in runtime. So in Statsig on the left-hand rail, you'll see feature management. Within feature management, you can go into dynamic configs. Here I have one dynamic config that I've already created, and this one is for ChatGPT 4o model. So we're going to go ahead and create another one for GPT 4o mini, which is what we created from Azure AI. So this one will give you a very untemplated, empty dynamic config. So we're going to go ahead and add an endpoint to this, which will be the endpoint that I copied from over here. And then I'm going to add, I think I'm going to add a key, which would be key. Copy from here. And then now we also have the ability to go ahead and add a set of like default parameters. So the default parameters, let me go ahead and copy this so I don't make mistakes, which would look like this: completion defaults, where you now have the option of specifying, things like frequency penalty, presence penalty, temperature, and so on, along with like, what the number of max tokens you want to apply. So let's, for demo purposes, let's go ahead and like change the max tokens to 60, and then for ChatGPT 4o mini, save this model. And once it's saved, you can copy this dynamic config ID. So the dynamic config ID allows you to provide one level of indirection so that when you go into your code, you no longer have to hard code the endpoint or the key in your code. So this is very important because as you're thinking about deploying something like this to various different environments, you don't want to like hard code your endpoint or your key. Sometimes you may want to, for security reasons, want to be able to invalidate them. And then if you do invalidate them, then your code becomes defunct and probably like crash. So you don't want that. You want some level of indirection. And so in order to do that, we made a very, very simple API, which is instead of calling get model client from endpoint, you can call get model client and pass in the dynamic config name. So this dynamic config name, like I said, already captures the model's endpoints, the model's key, and then subsequently also like some default values. And so we're going to use that and now pass in the same prompt. And because the dynamic config already has all of the configuration, you no longer need to pass in any more of these parameters hard-coded in the code. So let's go ahead and run this thing and see what happens. Let's see. Resource not found. So we need to remove these spurious extraneous paths. Let's go ahead and save this now. Okay, so now that the dynamic config is saved, we can go ahead and run this again. So this time we got another poem, but because in the dynamic config we have token length 60, that was cut short. So in order to show you that this is all like pulled directly from the dynamic config, I'm going to in runtime go ahead and change this to, let's change this to 200 and see what happens. So I will save this. And when I save this, all of these configurations is pushed out to various different endpoints around the world. And so when I call from here a dynamic config, now all that information is already propagated, and now you can see that this poem is much longer than before. So this is a very simple and easy way of like actually representing your model deployments within Statsig and then use it. Now, as before, we can go into the events and you can actually see all these real-time streams that are coming through. So this time around, you can see that, sorry, let me go back here. This time, you can see that the invocation was on ChatGPT 4o Mini, and we have completion tokens 200, and this time the API took 2.2 seconds. Okay, so now we have the ability to call into any one of these dynamic configs on the fly, and we've created these dynamic configs, and then we've also like started receiving all of these events. Now, the cool thing that we could do is the ability for us to convert any one of these events into a metric. So you could take these latency, for example, latency field from the metadata, and convert that into a latency metric. And now one of the things that we do with Statsig is like once you have a metric, you can now optimize for that metric. So you can like run experiments. We can have two different models. You know, in this particular case, you can have ChatGPT 4o and ChatGPT 4o Mini, and then run an A/B test against them and see which one gives you lower latency. So let's go ahead and like I'm going to show you today how to set up an experiment and run it. We unfortunately won't be able to see the actual results because an experiment will take like several weeks for the results to like show up, but we can actually like set it up and go, so you can go ahead and like play around with it. Meanwhile, I'm going to pause and see Skye if he has any questions or if there's anything that he wants to add along for now.
Vijay, just looking at a few questions in the chat. One that came through was, if you want to get started, can you just run through again like the exact steps that you need to take to start implementing this?
Yeah, so in order to get started, you will need Statsig account, which you can go ahead and create from statsig.com. You can create a free account right here, and that will give you access to a project like this, which you can then go ahead and use for this particular demo. We have a very generous free tier with lots and lots of events with all these features already packaged in, so you can get started today. You don't have to pay any, and you don't even need a credit card for that. Everything that we showed today is accessible from a free tier. Then the second thing that you will need is an Azure AI deployment. So in order to use any of these AI features, you need models, and these models have to be deployed. And that you can do from Azure AI Foundry, which makes it extremely easy to deploy any model.
Uh-oh, we lost Vijay. Okay, I think we can hear you now. I think someone dialed into your account in another Zoom room. I think I heard you say it extremely easy to deploy with Azure AI Foundry, and then I think we can still see your screen, so all good there. Um, another question that someone brought up, what would you recommend? So if someone has an existing Azure AI deployment and they're looking to start optimizing or running tests, what's the best surface to start experimenting on, or what's the easiest place to start if you want to test?
All right, can you hear me?
Yeah, we're all good.
All right, so sorry, repeat that question again.
So if someone already has an existing Azure AI deployment and they're looking to, they want to get started running an experiment or running a test, what's the best thing to start experimenting on? Or maybe what's the easiest test to run that would produce some interesting results?
Oh yeah, so we're talking about running an experiment, which is an A/B test. So we can. So what I'm going to show right now is how do you test two different models. So imagine you have a GPT-4o, and then you have a GPT-4o mini model. Which one is going to perform better? Performance could be measured in the form of obviously. If you have an application, you want to measure user engagement and retention and how satisfied the users are. So that's one way to measure the performance of a model. The other general ways of measuring the performance of a model is latency. How long did it take? Because additional latency means like poor performance or poor experience, and so that's one way to do it. Token length. So how many tokens is each one of these consuming? Because obviously token length is how you end up paying. So that actually is an optimization of cost. And so you can also do experiments that can compare those costs as well. So those are like several ways in which you can run the very simple experiment to measure and optimize for various different ways. I will show you an experiment right now, how to, especially using Statsig's dynamic config. So once you've configured two different dynamic configs, it becomes super easy to run an experiment. Any other questions, Skye, before I jump in again?
No, I think an example would be super helpful. And then I saw a couple more questions come through, so we'll share those in a second.
All right, perfect. So let's go ahead back into the dynamic config. I'm going to quickly overview what we've done in the dynamic config. And so if you click into one of these dynamic configs, you will see effectively what we've done is we've created an indirection for the endpoint, and then we've created an indirection for the key. So those are the two main values that we're holding in the dynamic config. In addition to that, we're modifying a set of defaults. These are completion defaults. These are usually hard-coded in code, but because we made it so easy to create all of these deployments in a dynamic config, we also have the ability to change them on the fly. So as your application is out there used by your customers or users, you can actually go ahead and modify these. So in order to make this a fair test, I'm going to keep both the models So this ChatGPT mini model and the 4.0 model, both tokens to be 60, max token 60. So I'm just going to go ahead and update this to 60 as well. So now we have two configs. And in order to run an experiment, let's go ahead and actually create an experiment in Statsig. So this is how you would go ahead and create a very simple A/B test in Statsig. So let's do GPT 4.0 versus GPT 4.0 mini. So that's the name of the experiment. I mean, obviously you can call it anything you want. Once you create an experiment, we'll see here, a very simple setup. Here you can build a hypothesis. We believe that 4.0 mini will be faster and cheaper. For primary metrics, for now, I don't have the latency metrics defined, so I'm just going to go ahead and pick all the core metrics. And in here, I have the ability to bifurcate traffic. So as users are coming into the experiment, we now have the ability to split them. And so we're going to split them evenly, 50-50. And in the control group, I'm going to basically say we're going to use 4.0. And then in the test group, we're going to use 4.0 mini. So this is how we will verify if a user gets 4.0 or a 4.0 mini, and then subsequently all the metrics that go downstream of all of the experiment, we will gather, and then we'll know where these metrics are associated. Okay, so let's go ahead and create a parameter, and the parameter would be model, and we will add GPT 4.0, which is the name of the dynamic config on the control side, and then GPT, I can't type, 4.0 mini. And this is the test variant. So now we have control variant, test variant already set up, and I will go ahead and save this, and that's basically all you have to do. So now we have two different variants. We have an experiment ready to get going. I'm just go ahead and start the experiment. So once the experiment is started, you can go to the diagnostics console, and then you can now start to record the logs as the exposures are being generated. So let's now jump into code. Now, once the setup is done, obviously one of the things I want to do is like copy the experiment ID. Once the setup is done, let's go back into code. And in code, you already have the model client, which is ready for us. So let's go ahead. Before that, let's see, Statsig. So I'm going to go ahead and add. Sorry, give me 1 second here. Get Statsig server. Now we have, okay, server.getExperiment. GetExperiment sync is the method that we need to call in order to like get the information about the experiment. And we're going to pass in a user object. In this particular case, typically if there's a request that is being processed by a server, you will have a user ID or so on. In this particular case, I'm just going to go ahead and user ID would be a random user ID, which would be date.now to string. Okay. I mean, obviously, you should replace this with the right user ID in your use case. Right now, I'm just using a temporary one. And then what we need to do is to pass in the experiment ID, and which will get you an experiment config. And this experiment config, if it was already taken in the user ID, has already determined whether this user should get a control variant or a test variant, and has already pulled in all the parameters that we would define for the control and the test variant. And so now all we got to do is like go ahead and get the experiment config.get, and then you will pass in the model, and then you'll pass in any default value. The default could be 4.0 for us. Model name equals. So this is basically the skeleton of how you set up an experiment and get the value from the experiment. After this is basically you pass in the model name into the model config. Everything else remains the same. So in this case, what I'm going to do is I'm going to comment out this set of code just to verify that if all these setup is working, and I'm going to just print out the model name. So hopefully every time I run this code, I'll get back different variants, and the model names would be different, and should evenly be split between the number of invocations that we have. So let's go ahead and run this thing. And first time we got 4.0 mini. Second time we also got 4.0 mini. I don't know why we're getting. Oh, there we go. So and this is why you don't toss the coin in a live demo. So anyways, we're now getting back control and variance evenly split, and we will go ahead and play with this now. We can pass that model name instead of hard coding that model name into the model client, and then everything else remains the same. We can go ahead and print out the poem and see what happens. But before I go do that, I can also go ahead and refresh this exposure. Every time I called get experiment, we have in turn created an exposure, and that exposure has already been gathered by Statsig here, and you can see that we have these exposures. So we got a bunch of tests and we got a couple controls, and these exposures also come with it the user ID that we generated, which is basically just the date, time, now ticks, and it also includes a whole bunch of information about the invocation as well. So all of this instrumentation is pre-built into Statsig. So you get all of this in real time, which is very powerful, especially if you're running experiments. You want to know whether the experiment setup is correct from day one or from hour one. You don't want to go for 2 weeks and then determine something went wrong. So all of these powerful capabilities are available directly on day one in a free tier. So let's go ahead and actually run the model invocation using the values that we got back from the experiment and see what happens. So in this particular case, we picked 4.0, and that's the response. Let's try again. Let's try a few more times. This one is 4.0 mini. This one's taking longer. And we got a response. This is the test. Obviously, these are two different poems. Every time you invoke, and this is one cool thing about the AI invocations is it's non-deterministic, which is really cool. So you get so many poems, and again, this is 4.0 mini. And we got 4.0 mini quite a bit. We got 4.0 now. So now we've invoked this enough times, we can go back into the system and see that these invocations also came through. These are the exposures in the experiment. Corresponding to it, we also will see events. And these events are usage and invocation. So you can see in usage the actual latency and token length and all of those parameters being logged. In addition to all of this, you could also log other metrics. So for example, in your application, if you have ability to get a thumbs up or thumbs down, so those are also very easily capturable, and you can log them into Statsig. So in order to do that, you would do something like server.log event, and then obviously now you have to pass in the user. So I want to capture this user here. And so now I can pass in the same user object in two different places. Log event user, and then now we pass an event name. So let's say satisfaction And now we can say either a number or a value. And in this case, what we're going to do is math.floor, math.random times 5. Okay, so this means it's just going to log any random number between, in this case, 0 to 4. All right, let's go ahead and run this again. It's interesting that the 4.0 mini is taking longer than 4.0 model right about now. So 4.0 is faster, right? I would have expected 4.0 mini to be faster. Okay, so let's go back to the events. Let's refresh this page. It's been sitting there for a while. You will see the usage events coming through, and there's now a new event called satisfaction. And in this case, you have the first one got a value of 4, second one got a value of 2. Obviously, you can customize this to however you need and what fits your application. That's basically come to the end of the demo. Obviously you can play around with the SDK in different, in the Python and .NET as well. We have other APIs to call, but for this particular webinar, we'll just wrap up with this and see if there's any more questions. Skye?
Yeah, I saw one other question come through, which was, can you run tests on non-model features also? Do you want to, Vijay, just want to share a little bit on, how would you, let's say you're using an AI model as a part of an application, but there's also non-AI components of that application. Can you also run tests on those other components of the application? And how does that work within Statsig?
Yeah, so the experimentation engine is pretty generic, which means you can run any kind of experiment you want. You can run marketing experiments, you can run product experiments, you can run back-end experiments, and we do this all the time. So once you have Azure AI SDK installed, one of the things that you'll notice in this line is I am getting hold of the Statsig's actual server SDK. Once I have Statsig server SDK, I can run any kind of experiment. It doesn't have to be model experiment. In this particular case, the get experiment sync is a pretty generic API that'll get you back either a control or any one of the test variants. So this is a multivariate experiment setup. So you can run an experiment that could show 2 different layouts in your marketing page and then get back the different variants and completely bypass the AI aspects of this and run a very non-AI experiment. And all of this data will go straight into Statsig the way I showed you, both on the diagnostic side in the form of exposure, as well as the events side in the form of events, custom events that you log. So if you have a marketing site and you want to measure conversion would be an event that you log, and then that means you can optimize the experiment for conversion, which will tell you which of those 2 variants is performing better for conversion. And you can run one of the things that we do internally at Statsig is every time we deploy a new library, say for example a new improved compression library, we run tests. And this compression library could bring you a better compression, but it could also use up more CPU or use up more memory, and we want to capture those things, and then we measure that. That's a backend experiment that we regularly run. Every one of the features that we launch for our customers in Statsig is also behind an experiment, because we want to make sure that we don't, at a minimum, not ruin or break anything that is already existing. And it's subsequently, we also want to see if this is providing any product lifts or engagement lifts and so on.
Great. Well, I think maybe just to summarize, Vijay, it sounds like just answering the question, people can test any component of an AI application sort of in the same place, or also expand to other types of tests using the same framework and project, but not just model inputs.
Yep.
Cool. Well, if anyone here has any other questions, feel free to share them. I think we're at time. Thank you very much for tuning in, and happy building with this new integration. It's pretty exciting times, and we're really excited to be able to support customers building with Azure AI.
Yeah, join us on Slack. Our Slack is available for everyone to come in. We are all hanging out there. We will answer questions mostly very, very quickly, almost in real time. So statsig.com/community. We'll see you there.
All right. Thanks, everyone.
Bye.